Okay. So test results, any questions on anything? Make sure you look at the ones you got wrong, because if you made like little mistakes, like forgot a parenthesis and they took it off for you or something like that, I'll take a look at it and I'll give you points back for that. It's not, you know. Yeah. I don't want, if you got essentially right, I don't want to like put you grade. Okay, any questions about that?
Nope.
As always, test corrections are due Monday. So make sure you add that to your list of homework for the weekend if that's something you intend to do. Okay, so we're going to start a new unit now. This is a really important fundamental topic as it relates to like future math, calculus, and it deals with limits, an idea called limits. Okay. So what a limit is a limit of function is a y value the function approaches as x values get closer and closer to a particular x value. Okay, the limit of a function is a y value. Function approaches as the x values get closer and closer to a particular x value. Now, this is unusual in math to use language that's not so precise. Like approaches, that's a little weird, and closer and closer. Well, how much closer and closer? It's not very precise, but it's an essential like thing that you have to use in order to talk about limits for reasons that we'll talk about. Okay, but that's the definition of a limit. So the notation is, let's say, limit, and then below it in like a smaller font, you'd say x arrow a, and then f of x next to it equals L. Okay? The a is the particular x value that you're approaching, that you're getting closer and closer to. F of x obviously is the function. And L is the y value that you're approaching. Okay? So, like, for example, suppose I have a function, and let's do it like a graph of a function. Suppose I have a graph of a function, and this function is x squared. F of x equals x squared. And I want to ask the question, find the limit as x goes to 2 of f of x. So all I would do is, this is x equals 2 right here. Right? All I'm going to do is I'm going to pretend like I'm a tiny bug and I'm walking along this function towards that point where x equals 2. And then I'm going to ask myself, what y value am I getting closer and closer and closer to? So what y value am I getting closer to if I approach that point on the curve? Answer. What y value am I getting closer to? 4. Definitely, right? Because this point right here happens to have coordinates 2, 4, because it's x squared, right? That point has coordinates 2, 4. So if I'm walking along the curve towards that point, I'm heading towards the y value 4. This limit, therefore, is 4. And in your brain, you might be saying, why do we even need this? We could just say f of 2 equals 4. We have notation for that already, right? Probably that's what you're thinking. Like, why do we need this nonsense, this imprecise nonsense when we have precision? F of 2 equals 4. And the reason is because not all functions look like this. Sometimes you have functions that have weird stuff happening, like holes or asymptotes or like weird like jumps and things like that, right? You can have functions that do weird stuff. But even with those weird functions, you can talk about limits. Okay, so what if you had a function that instead of looking like that, what if it looked just like that, except it's missing a single point? And that point happens to be right at the point 2, 4. Suppose this is the function g of x. Well, in this case, it's still true that the limit as x goes to 2 of g of x is equal to 4. Still true. But this one, it's not true that g of 2 equals 4, right? I can't say that because this function happens to be undefined at x equals 2. There's a hole in the function, right? So that's the reason why we have limits, so that we can talk about these two functions both like as having a limit of 4 as x goes to 2. Okay? Essentially what you do is you just ignore what's happening at the point. And you just look at, like, what does it seem like is gonna happen? Now, maybe it doesn't happen, maybe it does happen, but what seems like it's gonna happen? Like, if you're watching the movie and you're pretty sure how it's gonna end up, right? Like, how is it gonna end up? How do you think it's gonna end up? Now, maybe it's like an M. Night Shyamalan movie and there's a big zinger at the end and you're like, oh my God, that didn't turn out at all how I thought it was gonna turn out. That's like this function, right? Or maybe it's like very predictable Hallmark movie where you know in the first 5 minutes who's going to end up with who, and it happens. That's this kind of function, right? Or we can even have a function that looks like this. Maybe you have a function that's a parabola that's missing a point, but instead of just missing, suppose that point is actually just moved somewhere else. It's just moved there. It's still a function. It still passes the vertical line test, right? And in fact, it's still true. Like, suppose this is like each of x. It's still true in this case that the limit as x goes to 2 of each of x is 4. Still true. These are 3 really different functions. But if you totally put blinders on, and you just totally ignore what's happening at this point. Like, so suppose I just like scribble out that vertical line, so you can't see it. Can't see the ending of the movie, right? In all 3 cases. It kind of seems like it's going to do the same thing every time, don't you think? Don't you think?
Yeah, unless you ignore it.
Which is what we're going to do. We're going to ignore it.
You gotta ignore it.
What's up?
I'm gonna ignore it.
Okay.
You're busy, I'll talk later.
Okay.
Ignore me. Who's there now?
Indeed.
It was late a minute ago.
A minute ago.
She just did it in class.
You know what I got going on back there.
Okay, so do you understand the idea? You have to essentially ignore what's happening at that point and just look at what does it seem like is going to happen? What does it look like the y value is going to do? Does it look like it's going to 4? Yes, it does in all 3 of these situations. Whether it actually ends up there or not, maybe it's totally missing, maybe it's just moved to another vertical location. Either way, these all seem like they're going to 4. So in all 3 of these cases, the limit as x goes to 2 is 4. Does everybody understand the general concept so far? Kind of an easy thing, but at the same time, it's a little abstract and weird, okay? So in this case, in all of these cases, you're kind of headed toward the same thing, right? From either direction. I happen to draw this like I'm walking along the curve in this direction, but I could have been walking along the curve going this way as well. And I still would be headed down towards y equals 4, right? In all three cases. In some cases, that might not be the case. You might have it going towards one y value from one direction and towards another y value from a different direction. That's possible. Those are called one-sided limits. So you can have one-sided limits where you only consider what's happening to the y values from one side, okay? So the notation for that is the limit as x goes to a, and then a superscript on that. So like a little superscript minus sign would indicate that as you approach a from the left, that's what that superscript minus sign means. It means from the left. So this is like from the left. And the opposite notation would be the limit as x goes to a, and then a superscript plus sign. F of x. And this just means from the right. Now, in each of these cases that I've already given examples for, the left and right-hand limits are the same, right? Like in this case, I could have written the limit as x goes to 2 from the left, f of x equals 4. That's true. If I am walking along this curve from the left of 2, but towards 2, towards x equals 2, the y values are going towards 4. Or the limit as x goes to 2 from the right, 2 from the right, f of x, that's also 4. If I'm approaching that point on the graph from the right-hand side, I'm also approaching 4. So I could have written these one-sided limits here, and they would have been both been 4. And the one-sided limits here, and they would have both been 4. But you might have functions where the one-sided limits are different from each other. Okay? So you might have something like, suppose you had a piecewise function, which we've talked about. And suppose this piecewise function looks like this. Let's suppose it's a parabola that kind of goes like this. But then right when you get to 1, it turns into a horizontal line like that. Let's say that's the function, f of x. So they might ask you to find the limit as x goes to 1 from the left. So you just ignore this whole side of the function. And you just say, I'm a little bug walking towards that point on the graph. What y value am I getting closer to? 0. So this left side limit is 0. Great question. Limit as x goes to 1 from the right, f of x. Same scenario, but this time I'm walking along the curve right here to the right of x equals 2. What y value am I getting closer to? 1. In this case, it's like constantly 1, but still I'm getting closer and closer to 1, right? So this one-sided limit would be 1. They're not equal to each other.
This notation seems more complicated than it is. Yeah.
How could we simplify it?
Right. Just say, oh, it's 1.
What's 1?
L equals 1.
Yeah,
L equals
yeah.
0, whatever.
But you have to know what x value you're approaching. I'm trying to convince you that it's as simple as it can be. You need all the information that's here. You have to know what function you're talking about in case there's more than one. You have to know what x value you're going towards, right? Because if I give you the same function and I said find the limit as x goes to 2, what would you say? then it would just be 1 from both directions. So you have to know what x value you're approaching. You also have to know which direction you're approaching it from. If I don't have a superscript, then you just assume that it's going to the same place, I guess, right? So you need that. You need that. You need, like, there's nothing you don't need here. Right?
On Delta Math, but we have to write all that out.
No, I mean, I can't remember how the problems are. But
Wait, are there arrows?
let's look at some
Find a
problems.
little arrow.
Wait. Couldn't they simplify it if they just use a symbol instead of running out?
Well, they shortened limit. They wrote LIM.
That's just showing the get.
What symbol do you think they should use?
Just use a symbol so that you know that it's a limit, and then you can have the plus or minus superscript, and then just the x value instead of x approaching.
Okay, so you're saying, like, instead of this, why don't we just write L, like, 1 minus that, something like that.
Yeah.
Instead of writing this, you're saying, let's write this.
Like, I was back.
Is that what you're saying?
It's any symbol.
Where do you find the little arrow? Is that on my keyboard? Do I have tiny arrows?
No.
No. I want a tiny arrow.
Okay, so yeah, I guess we could have it be a little simpler. But really, I mean, this isn't so bad. Let's not complain too terribly, right? I mean, I could have written these words. As x is getting closer and closer to 1 from the left-hand side, f of x is approaching 0. Like that's what we're shortening down to this. So let's not get greedy.
I'm just saying, if you showed that to me like a couple of years ago, I would have had like no idea what it was.
Well, of course. So let's look at some delta math problems, and you'll see how they are. They're actually very clear. You don't have to do these symbols or anything like that.
That's the kind of stuff that I like the background. Like we used to do that before.
So this assignment is called graphical one-sided limits. So if I click on it, they give you a function. They give you a piecewise function, and they want you to find the limit as x goes to -3 from the right-hand side. So you're just thinking to yourself, okay, this is x equals -3. That's the value that I'm ignoring what's happening at that point. All I care about is what's happening close to that point. That's what limits are. What's happening close by. And from the right means from the right-hand side of that squiggly line. What y value am I getting closer and closer and closer to? The answer is 2, so you just type in 2. That's it. Okay, so I would just type in 2, submit, and abracadabra, that's the answer. All right, let's look at another one. Now, something like this, without even looking at the function, what are they asking here? Yeah, here they're saying, actually at that point, what is happening? What is the y value when x equals 2? So now you look at this, and the answer is 5. This is an open circle. This is a closed circle. It has to do that. So the answer would be 5, right? So if they ask you for a limit, they're saying, what's happening nearby? If they're asking you for the value of the function, f of 2, f of 0, f of -1, whatever, they're saying, at that point, what is actually happening? How does it actually end? Limit as x goes to -2 from the left. What's the answer? Nope. That's from the right. From the right-hand side, approaching that, I get 6. But from the right-hand side, that's this part of the function, I'm approaching -4. The answer should be -4. See the difference? Now, people get a little bit confused about this, and they go, negative, that means towards the left. And this is towards the left. But that doesn't mean towards the left, it means from the left, right? So if you're approaching from the left, you're actually going towards the right, towards the positive direction. So I get how that's a little bit confusing, but you just got to get it straight. Negative means from the left-hand side, positive means from the right-hand side. So this answer is -4, correct? Put another one. In fact, let's go around the room and see if every single person can answer one correctly. Hunter, you're first.
What?
Yeah, word. What's the limit as x goes to 4 from the left? The limit as x goes to 4 from the left.
Oh, I know this one. Can I answer?
It is absolutely 1. Everybody see why it's 1?
Yeah.
From the left-hand side, those y values are going towards 1.
It definitely is one.
Garrett, are you ready?
Good.
Limit as x goes to -4 from the right-hand side. Absolutely correct. Bailey, from the left.
Hello?
Same question, but from the left.
Negative.
-6. Everybody cool with this so far?
Yeah. Is it always? Yeah.
That's what it seems like.
Yeah.
Yeah. Yeah.
Sienna, what's the limit as x goes to 1 from the left? Correct. 3 from the right, correct. Limit as x goes to 2 from the left. What is it? 4 from the right? 5. This is easy, isn't this easy?
Yeah.
Limit as x goes to 3 from the left. Correct. From the right? 1.
Let's go.
Limit is, or, whoa, different question. F of 3.
Oh, what is
It's
this?
trippy up. Undefined.
Undefined. Does not exist.
I did it.
Down here, you would just click undefined or does not exist.
Wait, what did they have both?
Either one. Either one's acceptable.
For both, so mine would be undefined.
Well, I'm going to give you a different one. Limit is x goes to 3 from the right.
That negative.
Correct. From the left? 5. Last question.
Hard one.
Limit is x goes to 1 from the right.
From the right?
Yeah. Wait, what'd you say?
3.
Oh, that's right. I didn't hear you. Sorry.
Oh, I was like.
Sorry. What is it from the left?
5.
Correct. Any questions? This stuff's kind of easy, right? Okay. If we get to the end of this unit and you're like, what do we do? This all seems so stupid and easy. Then you're on the right track because this stuff is really stupid and easy. But you know, if so on the flip side of that, if you're still not quite getting it, just keep being persistent. The light bulb will go off and you'll be like, I can't believe I didn't understand what I was doing. That's so easy.
You can make the notation.
I don't have.
Okay, what would it
I
be?
didn't write like.
Okay, so do like a person or a capital L, and then you can put just a regular L or a regular R. Determine from the left, from the right.
Like next to it or a subscript?
How many sleeps a day?
Okay.
Right,
I don't
wait,
L or R.
press,
And then the next value that you're putting.
doesn't write like.
Maybe you can put here.
Or 1 or whatever. And then the function. You gotta have a function.
Yeah.
Is that less ink than this?
Yeah. And I'm like a 90. Instead of a 93.
I used way more ink here than I did there.
Wait.
You could have made it like a
You
regular.
like it here, and I was nice.
Trying to prove you wrong, yeah. The only problem with using a different notation is nobody in the world will know what you're talking about.
Based on like,
Aside from that,
based
I
on
totally
like
agree with you.
our class, so it's like.
Someday, if you are emperor, you can change those sorts of things.
You just got to know.
Yeah, yeah. All right, so I have a discrepancy with your notation. What if you are a Spanish speaker, a native Spanish speaker, and the word for right isn't right, but it's like derecho?
No, you used a minus and a plus, didn't you? Like in his notation?
No, I used R and
L.
Well, then that's your solution, just use a minus and a plus.
Yeah,
There you go.
so there you go.
No, but then like he said, like, is it -5 or is it 5 from the left? If you have minus and then a 5, is that approaching 5 from the left or is it approaching -5?
You should have it be like a subscript. It's more obvious. And then you're not just like guessing as to what it is.
Or we could just stick with the same notation that's been around for 2,000 years.
Or you can just use arrow.
Who made this
You can
notation?
just
Who
use
was
an
it?
arrow.
Actually, it was
That's just a symbol, it's not even like, you don't need it like that.
an arrow. Like, how so?
You do L, and the arrow from the direction you're approaching from.
That would work. This, by the way, this was all, I think it was in the 1600s maybe. Isaac Newton did this. He invented calculus. So I think it was the 1600s. Does anybody know for sure? Isaac Newton? No, I think it was the 1600s.
Man, I wish I could do smart things like that. That'd be cool.
What's that?
What if
Oh, yeah.
the
Someone's gonna watch this later.
I think it's better.
I think